Given a continuous time signal x of t, it can be converted into a discrete time signal x of n using a process called as sampling. In our course, we'll only consider a sampler that samples at a constant rate. In a discrete time signal, as its name implies, the time index is discrete, which means the signal is only defined at discrete values of time. In this figure, a sampler is an idealized switch which closes to sample the input continuous time signal after every ts seconds. When the switch is closed, the value at the input is captured at that instant and the switch is open again. Let us assume that this ts or t is 1/8 of a second, which will mean that our sampler is capturing the values of the continuous time signal 8 times every second. We now introduce some terminology. This value t or ts is also called as the sampling time. The inverse of t is called as the sampling frequency and is denoted by fs. Here at the output of the sampler, we have a discrete time signal which is denoted by x of n with a square bracket. Here n is clearly an integer. This means that the discrete time signal is a signal whose value is defined only when the sampler closes at integer values of n. Otherwise, the value is undefined. We use the notation x of t for the continuous time signal and the notation x of n for a discrete time signal with square brackets. In this example, a discrete time signal is nothing but a set of values x0, x1, x2, x3 and so on, which also corresponds to the value of the continuous time signal at the times 0t, 1t, 2t, 3t and so on.